Hello, Algebra 1. We are doing lesson 11.4, multiplying and dividing rational expressions. I think most of this you're going to like because it's I think you'll find it fairly straightforward. It's like, oh, well that really isn't much of anything new. The dividing has one new component that you also kind of know already. So, hopefully it goes well. But here we go. So this is 11.4, and it is multiplying and dividing rational expressions. So we have oops, slip that L in there. Multiplying and dividing rational expressions. Okay, so the multiplying. We can just point out a couple things and then look at some examples. So we can say numerators multiply to other numerators. Multiply, I'll say multiply with other numerators. And then same thing but denominators. Denominators multiply with other denominators. And then I could also say before and after multiplying. Keep an eye out for things that simplify. And that's like lesson 11.3 kind of stuff, simplifying rational expressions. Okay, so let's do some examples. Here is our first one. Oh, I gotta flip back a page. Hold on a second. There we go. Let's do x to the fifth y over 2x cubed times 18z to the fourth. Oh, I'm sorry, that was a 2z cubed. 2z cubed times 18z to the fourth over xy. Okay. So, numerators multiply with other numerators. So, in other words, this x to the fifth y is going to multiply by that 18z to the fourth. And then denominators multiply with each other. So this denominator is going to multiply with that denominator. All right? So there's that piece. But then also before and after multiplying, keep an eye out for things that simplify. Now, because this is all multiplication, all right, what we have is we have x to the fifth y times, or really x to the fifth times y times 18 times z to the fourth, right? Z to the fourth, yeah, that 4 looks a little wonky. Let me make that a little bit better. Okay. Same thing on the bottom, we have 2 times z cubed times x times y. It's all multiplication. And so because of that, you can cancel, you can simplify before or after combining these or multiplying these together. So for example, if I had, let's just say I had, how about this? I had a squared b to the fourth c over c squared d e to the fifth. Okay. Now what can cancel there? Or what can simplify? The c's, right? And so this is technically a c to the first. So this this one c, or if you go the direction of, okay, you have a c on top and a c on the bottom. Is it bigger? Is the power bigger on top or on bottom? Oh, on the bottom. By how much? By 1, because c squared compared to c to the first, it's 1 power larger. So you end up with a c to the first on the bottom. So this cancels with that, and you're just left with a c on the bottom. Okay. Now, it didn't matter that this c was at the end and this c was at the beginning. And it doesn't matter. If they're all being multiplied by each other, and you have one thing on top and this matching base on the bottom, then they can still cancel. So similar to that, I'm going to erase all of that because it's not directly related to the problem, more just an idea. Because of that, this x to the fifth can simplify with this x, even though this is in the first fraction and this is in the second fraction, because we're just all, this is just a bunch of multiplication. But if it's easier, you can multiply it out first. So you could say, well, let's see, what is my top multiply? My top multiply is to be 18x to the fifth, y, z to the fourth. I multiply the numerators. Now I can multiply the denominators and put stuff in the regular order of number to, and then letters in alphabetical order, x, y, z cubed. You can do that as your first step if you would like. Then you can look for what simplifies. All right, well, let's see. 18 over 2 simplifies to 9, because 18 halves is 9. X to the fifth over x to the fourth, x to the fifth over x simplifies to x to the fourth on top, because you have a power of x that is 4 times bigger, 4 times bigger on top. The y's just flat out cancel with each other. And let's see what happens with the z's. We have a power of z that is bigger on top. How much bigger? 1. So we have a z on top. And everything on the bottom canceled with just a 1 on the bottom. So I'm just going to get rid of that, and that is my answer. 9x to the fourth z. So that was with multiplying it. Or you can do the same thing, but with what you started with. And you can just say, well, let's see, my 18 over 2, that's 9. My y's cancel. My x's, my x to the fifth and x to the fourth, so that's going to leave me with an x to the fourth on top. Sorry, my x to the fifth and my x. And then my z's, let's see, is z cubed, z to the fourth. Z is 1 power bigger on top. So I'm going to have a z to the first. So what am I left with? Well, everything canceled on bottom, so I'm just left with technically a 1, because it's 1 times 2 times, etc. And what am I left with then on top? 9x to the fourth z. Same answer. So whichever method you prefer there. All right? So that's an example like that. Let's do one that looks maybe a little bit different. This one is like this. Here we have y plus 6 times y minus 1 over y plus 2 times y plus 1 times y plus 2 over y plus 1 times y minus 1. Okay. Now, sorry if I scroll more than I wanted to get that stuff up at the top in view just in case it was helpful, but I don't think we're particularly going to use it much right now, so I should probably just kind of go to a blank area like that and just leave it. So here's what's going on with this one. All of these chunks are just being multiplied by each other, as in my numerator, I have a y plus 6 times a y minus 1 times y plus 1 times y plus 2. And then in my denominators, I have a y plus 2 times. Now, what you have to be careful of is it is this whole y plus 2. This is not like y plus 2 times y plus 1 times y minus 1. It's y plus 2 times y plus 1 times y minus 1 in the bottom. Okay? Again, it is not y plus 2 times this stuff. It's y plus 2 times this stuff. So then what that does, we can look for, I personally would look for what cancels. Do I have any factors? In this case, our factors are our binomials, are two terms inside of parentheses. And I would look and I say, let's see, I have a y plus 6 on top. Do I have a y plus 6 on the bottom? No. I have a y minus 1 on top. Oh, I also have a y minus 1 on bottom. What's y minus 1 over y minus 1? 1, because anything over itself is 1. I have a y plus 1 on top and a y plus 1 on bottom, so those cancel. I have a y plus 2 on top and a y plus 2 on the bottom, so those cancel. So what's my answer? What I'm left with, y plus 6. Oops, I don't need the parentheses though, because it's all by itself. It's not being multiplied by stuff. So my answer is y plus 6. Hopefully that makes sense. Let's do one more multiplication example. This one looks like this. X squared plus x minus 2 over x plus 2 times 4x over x minus 1. All right. So we could do some multiplying here right off the bat. In which case it would be this whole chunk, x squared plus x minus 2 times 4x. I could do that. I'm going to get an x cubed going on as my first term because the x squared times 4x is going to give me a 4x cubed. But what you want to look for first is, can you factor? So we should ask ourselves, can I factor that? Because if I can factor that, hopefully there will be either an x plus 2 or an x minus 1, maybe even x plus 2 and an x minus 1. There will be some combination like that that will end up canceling with stuff that is here. Because it's nice when stuff on top and stuff on bottom can cancel each other. So I need to see if that x squared plus x minus 2 can factor. So it's a 1x squared. So this again is where I can just pull that negative 2 and look for two numbers that multiply to equal negative 2 and add to equal a positive 1, because this is a plus 1x, a positive 1. So 2 and negative 1. 2 times negative 1 is negative 2. 2 plus negative 1 is 1. So then this numerator factors to be x plus 2 times x minus 1. And I have still have this as over x plus 2 times 4x over x minus 1. Now I can look for what cancels. I have an x plus 2 on top and bottom. They cancel. I have an x minus 1 on top and bottom. They cancel. And I'm just left with the 4x. And that's my answer. Okay? So sometimes you'll have to factor in order to see what can cancel. The other direction this could have gone, but it's just, I don't recommend doing it this way. I always recommend check first to see if you can factor, is if you multiplied this x plus 2 times this x minus 1, you would have ended up with, on top, you would have ended up with x squared plus x minus 2 times that 4x. And then on the bottom, you would have ended up with x squared plus x minus 2. In which case then that whole chunk and that whole chunk would have canceled, leaving you again with just the 4x. But factor, that's what I recommend. All right. with the division. Now we look at division, or I'll say dividing. Wait, how did I say it up top? I'm going to scroll up. Yeah, I did say multiplying, so I want to say dividing. Dividing. Step 1. Invert the second fraction and I think my pen just might have died. Weird. I say weird because I haven't used it in a while, and oh, nope, that appeared to work. I think something is just going slow with it. Anyway, it charges super quickly just in case. Yeah, it just suddenly wasn't writing. Okay. Invert the second fraction and multiply come on. There's some kind of lag going on. I'm not quite sure why. Multiply instead of divide. More on that in just a second. Then you just have multiply and simplify. Come on. Yeah, something is not quite working right. Multiply and simplify. Okay, so what's going on with the invert and multiply? Maybe I could explain it like this. If you take a cake and you divide the cake in two, okay? You divide it into two pieces. The other way of looking at what you've just done is you have multiplied the cake by 1/2. Okay. Multiplying by a half leaves you with half of a cake. Taking a whole cake and dividing it by 2 leaves you with half of a cake. So multiplying by 1/2 is the same thing as dividing by 2. And what's the relationship between 1/2 and 2 is they are reciprocals of each other. In other words, well, here's kind of what we're saying. Dividing by 2 is the same thing as multiplying by 1/2. And 2 over 1 is a reciprocal of 1 over 2. Okay? That's what's going on. So really you just take what you're given, take the second fraction, flip it upside down, and instead of dividing, multiply, and at that point it's just like the same kind of problem that we were just starting with. So let's do a couple like that. Here's our first example. Let's do 8 over 3x squared divided by 4 over x. I've been hearing some of the thunder outside, and I think maybe it's starting to rain too, but definitely been some good thunder going on, and I want to go take a look, but I'll finish this first, and hopefully it'll still be going on. All right, so what do we do first? We invert and multiply. So we rewrite this as 8 over 3x squared times x over 4. So instead of divided by 4 over x, we multiply by x over 4. And now we just look for what simplifies. Well, let's see. The 8 and 4, 8/4 is 2. You know what? I am going to not write it like that. Okay. Just because I don't want to clutter up what I did for that first step. So this is the same thing as 8x over 12x squared. Okay, now I can look at what's going on. Let's see. 8 over 12 is the same thing as 4, 8, 12 is same as that's 2/3. 2/3. And then x over x squared, the x power is bigger on bottom, it's bigger by 1. So I'm left with an x. And that's just kind of wonky how I wrote that. So I'm just going to rewrite that as 2 over 3x. That is my final answer. Now, a word of warning. I think some of you might be tempted to write this as 2/3 x. That is not the same thing. It's not the same thing. Because this x is technically on the top, because this is an x over 1, in which case it would be 2x over 3. That would be putting the x on the top. The problem that I have here, the x is on the bottom, is 2 divided by 3x. So I can't rewrite that as 2/3 x. So you have to make sure that it's really clear that that x is on the bottom, because that's where it is. Okay? All right, another example. This one is y squared plus 6y plus 5, y squared plus 6y plus 5 over 6y plus 6 divided by y plus 5. Okay, so that's what you're given. Now here's what I recommend you view it as. This y plus 5, view it as a y plus 5 over 1. It's going to make the inverting easier to view. So when we invert this, the first one stays as it was, y squared plus 6y plus 5 over 6y plus 6, now times 1 over y plus 5. That's the invert and multiply. My y plus 5 became 1 over y plus 5, and my divided by became times. All right, so now this should be kind of like looking like one of the multiplication problems we did, where we have this polynomial here, this quadratic polynomial that we should factor. So I want two numbers that multiply to be 5 and add to be 6. Well, 5 times 1 is 5, and 5 plus 1 is 6. So this multiplies to be y plus 1 times y plus 5. Okay. Now, can I factor anything out of the bottom? Well, they have a 6 in common, so I can factor that 6 out, and that will give me 6 times y plus 1. And I still have this times 1 over y plus 5. Now I can look for what simplifies or what cancels. Y plus 1 on top cancels with y plus 1 on the bottom. Y plus 5 on top cancels with y plus 5 on the bottom. And I'm left with 1/6. That's my final answer. Everything else simplifies out. Okay, great. Then the homework gives you so with this topic, there's also unit conversions. Unit conversions is kind of an application of we are dealing with here. So unit conversions. Which is also known as dimensional analysis. Dimensional analysis. In other words, analyzing what dimensions are that you're dealing with, which is like another way of saying what units are that you're dealing with. There are a couple things that we use. We'll say use multiplying by 1 as a tool. So what do we mean by multiplying by 1? Anything or what's on top equals what's on bottom. So, for example, I can say 1 week is 7 days. If what's on top equals what's on bottom, this equals 1. And I can multiply without changing the quantity of what I'm dealing with, right? In other words, if one person said, I'm trying to think of what you would do, like, I was out of state for 1 week, and another person said, I was out of state for 7 days. Did those two people spend an equal amount of time out of state? Yes. They're just expressing it in two different ways. We could also say stuff like this. Stuff like uh, one, no, how about, how we go like this? 3 feet is 1 yard. Okay? And I can flip that upside down. I could also say 1 yard over 3 feet. Likewise, I could say something like 5,280 feet is 1 mile. Okay? All of these equal 1. They all equal 1 because what's on top is equal to what's on bottom. So because they're equal to 1, I can take some quantity and multiply it by these and use that as a tool to convert the units. So that's one thing. So you use multiplying by 1 as a tool. And the other thing is get rid of units on top by canceling them. I think that has one L, but oh well. Canceling them with the same unit on bottom. Man, struggle is real. On bottom. And vice versa. And vice versa. So, for example, let's just say I had initially like let's just say 1 yard. And these are technically on top. Okay, and I'm wanting to get some expression in terms of miles. So yeah, let's say yards to miles would look like this. I have 1 yard. That's technically on top. I multiply by a fraction that equals 1. What's on top is equal in length to what's on bottom. And I want to get rid of yards. Yards are technically on top. If I want to get rid of yards, I put yards on the bottom. So I would say 1 yard. What's equal to 1 yard? 3 feet. So now yards cancel, and I'm left with feet. Okay. Now I'm wanting to go to miles, right? That's M-I-L-E-S, miles. I'm wanting to go to miles, so I'm going to multiply by another fraction that equals 1. And I don't want feet anymore. I currently have feet on the top. I want to get rid of feet, so I'm going to put feet on the bottom, and I want miles on top. So what do I know about the relationship between miles and feet? Well, I know that 1 mile is 5,280 feet. So now my feet here cancel with my feet there, and I'm left with 3 over 5,280. I'm left with 3 over 5,280 miles. In other words, this fraction is how much of a mile 1 yard is. 1 yard is 3 over 5,280 miles. Okay? So what the problems are going to look like that you're going to have will be stuff like this. Let's say we know the following information. If 1 mile equals 5,280 feet and 1 meter equals 3.28 feet, and 1 kilometer equals 1,000 meters. So M is meters. If you want to abbreviate miles, it has to be MI dot. MI dot is the abbreviation for miles. M is the abbreviation for meters. And we also know that 1 hour equals 3,600 seconds. Convert 50 miles per hour to meters per second. Second, you can either do SEC or just S. All right. So let's start out writing what we were starting with, 50 miles per hour as a fraction. So we're going to go 50 miles over 1 hour. And we want to get to meters per second. So you can either work on going from miles to meters first or from hours to seconds first. I'm going to go miles to meters. Okay, so what can I use that cancels miles? So I know I want something with miles on the bottom, and I want to try to get to meters. What do I know? I know that 1 mile is 5,280 feet. So when I do that, miles there cancels with miles there. Now my units are now feet per hour, But I don't want feet per hour, I want to get to meters per second. So do I have a conversion between feet and meters? Because I didn't have a conversion going from miles straight to meters. But I had miles equals feet, and I have feet equals meters. So now I have feet on top. I want to get rid of feet, so I need to put feet on the bottom now. So I'm going to put 3.28 feet on the bottom. 3.28 feet on the bottom. And that equals 1 meter. So now my feet and feet cancel. Now my units are, I have 50 times 5,280 times 1, all of that divided by 3.28 would be meters per hour. But I don't want meters per hour, I want meters per second. So I need to multiply by another fraction that hopefully will take me from hours on bottom to seconds on bottom. So I have hours on bottom. I want to get rid of hours, so I need to put hours on top. So I'm going to put 1 hour is 3,600 seconds. Now, my hours here cancel with my hours there. And what units do I have left on top? Meters. What units do I have left on bottom? Seconds. So now I just need to do all the multiplying and dividing. So what I have on top, as far as the numbers are concerned, I have 50 times 5,280 meters over 3.28 times 3,600 seconds. The way I personally do this in my calculator is I do 50 times 5,280. Any number that's on top, you multiply. Any number that's on bottom, you divide. So I do 50 times 5,280 divided by 3.28 divided by 3,600. Because these numbers, I'm dividing by 3.28 and I am dividing by 3,600 because the 3,600 is also in the bottom. So then when you do that, 50 times 5,280 divided by 3.28 divided by 3,600, you get 22.36. I think I'll say round to the 10th. So that'd be 22.4. So my answer here would be 22.4 meters per second. So that's how you would write your answer. Or you could spell it out meters, METERS, PERSECOND, meters per second. Okay, so that's that. And then you have one other kind of problem that is like this. Find the product and describe. Find the product and describe